Alright, we're out here today at what I call our solar shed. It also serves as our pump house for our water tank and the water that supplies the house. But today we're going to be putting in a 48 volt battery charger on the well pump battery pack or battery bank. And that's going to be our battery right here, which consists of 4 12 volt AGM batteries. Got them from Walmart. It's the Everstart brand AGM Platinum series. Here's some more stats. Looks like we got 95 amp hours. So this is in series to create a 48 volt battery bank, 95 amp hour, which is our sole battery power for our well pump, which the controls are over here. This controller goes straight to the well pump that's down about 400 feet and supplies the water to the water tank, and thusly gets pumped through our manifold system here and our pump up to the house and other sources on the property. But the main thing today is I would like to have, because we don't pump the water all the time, only occasionally, say once or twice a week, to top off the tank or to add water to the tank if we're using it for some other sources like filling the pool or ag watering or anything like that. If we need to get water into the tank fast, we want to make sure these batteries are charged up and ready to go, because it is a DC pump. Also, we have the inverters charging from the solar panels, charging our main 7 kilowatt battery made out of LG Chem batteries, 2.1 ends, and a 14S configuration for another 48 volt battery pack. But that is for the pumps that are pumping to the house. So ours are supply pumps, not our well pumps. We have two batteries, one for the pumps pumping to the pressure tank and up to the sources, the house, and the hose bibs, and then we have another battery pack just for the well pump. So we have noticed that sometimes the battery does get low, and we want to have kind of like a tender or a trickle charger on the batteries, to keep them topped off. So go ahead and put that on today. Go ahead and open it up here. So this will kind of act as a unboxing and a review. I've never seen or used this one before. It was recommended to me for 48 volt application, both in sealed, flooded, and AGM batteries, which are sealed. Comes with a warranty card, instructions, its power cord, and the unit itself, which I'm glad to see that it just has the alligator clips on there, which makes it nice and easy. But if it doesn't make a good connection, I'll probably end up putting ring terminals on there, but I think this will do just fine. Go ahead and try to do this with one hand. These twist ties are never fun. Alright, we got that off. So I'm going to go ahead and put positive, positive, negative, negative. That's pretty self-explanatory. This side of the battery pack is our positive. You can see how the series goes from main negative, series connection, series connection, series connection, main positive. We'll go right here. Since these are very small, I don't think we can do more than just put it right off the post. And then main negative right at the end. We had a little spark there. That's pretty standard. Take off the twist tie on this one. Go ahead and put it into our power here. This is being powered by the solar, so kind of a backward system at the moment, but until we get something better, this is what we're going to do to keep these topped off. We're using DC to AC, AC back to DC. We're definitely going to lose some efficiency there, but we're generating way more than we're using at the moment, so at this point, anything to use that excess power is going to be okay. You can hear the inverter in the background kick on, so we definitely are getting some amp draw, and it looks like we're charging. Has a battery charging plus an indicator saying that we're about 80%, 75, 80%, and charging at last 25%, so that's good. And then we're going to go over here, turn on our well pump, which is just a breaker here. I also have this hooked up to an Alexa relay so I can control it from the house, but I turned it off for this video. So green light indicates the system is getting 48 volts. This is a 48 volt system, and in a second here we should see a light for the pump. Not seeing it right now, but it kicks on within about 30 or 40 seconds. But in any case, it looks like we are getting a charge, or the tender is working. Let's go to our solar and see how many amp or watts we're pulling. I'm going to turn off everything but the charger and see how many watts we're pulling. Right now we are in battery mode, so we're taking power straight from the solar panels into the battery, but we also have this set up for direct source of the solar panels to be used for the output source. So it only looks like it's pulling about 60 watts, 57 watts, which is not a ton, but it's enough to keep these topped off during the day and eventually be topped off at night, so we can use these during the night if we have an emergency. But let's look at the back here and see what it's rated at. It looks like we have 55.2 volts output at 1.5, so that's roughly about 80 watts. So it's not pulling full output right now, but that's pretty close. And I wasn't expecting much more than this. 50 watts or 50 to 100 watts is plenty of power to keep these topped off. And as you see, it's kind of ramping up. We're bouncing between 55 and 67 watts. But for the meantime, and of course I'll clean up all these wires, but in a future video I'll probably get into explaining my setup here and what I've done and when it's running, and the breaker and the wiring that I've done and how I'm getting power to what. And eventually having these batteries installed. These are a lot of the 2.1N LG Chem batteries that I'm going to be using for these MPP solar PIP controllers, or PIP solar chargers hybrids. These are the standalones, or the full off-grid with a transfer switch. But again, I'll feature all this in another video, so people who have questions on these can ask in the comments, and also on the plumbing side of it. But for now, looks like everything's working for this charger. We're still blinking charge. We're hooked up with the 48 volt pack for the well pump, and that's running right off of the AC output of our solar, which is powered by the array outside. But for another video, thanks guys for watching. Got any questions, leave some comments in the area below, and don't forget to like and subscribe. Thanks everybody. next time.